Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello, and welcome into the Computer America Show, everyone. I hope that you're doing well and you are ready for today's segment. And of course, today, as I'm sure that you've seen the title and everything's going well. If you're watching us live, thank you so much. But we have the one, the only Mr. Ralph Bond. He'll be joining us here in just a moment, and that's we have a number of stories, I believe 4 different stories that you may not have heard about that you definitely want to. And it's going to be a lot of fun. So it's kind of our way to say happy Friday, everyone. I hope that you're doing well, you're ready for the weekend, and hey, we can send you out on a high note. So with that being said, though, computeramerica.com, that's where you'll find everything, including past shows, future shows, everything you need to know, including, links to Ralph's website, links to the articles and the stories, and of course, we also have a couple of reviews and articles and just other things that we do here on the program. As far as Computer America goes, it's the best way to find out everything. The latest one is honestly just like for people who hate reading, it's a bunch of pictures from Apple's spring event, and it's really the screen caps of just the high notes and what they announced there. Really simple. You can check that out over at our website. Now, with that being said, let's go ahead, bring Ralph on, and just get the show started. So, everyone, as said before, Ralph Bond, he is our science and tech trends correspondent here for Computer America, and longtime correspondent. Love having him. Ralph, how you doing? Welcome back onto the program.
Hey, it's great to be back. And once again, just like last week, in this era of all this doom and gloom, horrible stuff that's going on in the Ukraine, you and I can we together can give our audience some uplifting news thanks to the world of science and technology. Absolutely. And I think that's going to be, obviously a huge theme going through here because, science technology covers a lot of fields. But for you, it's really boiled down to a couple fields where medical stuff, always fun, new materials and construction and projects like that. I mean, just give us a quick overview about when you come on the show, which stories do you which story do you tend to gravitate towards? Well, I gravitate towards stories, Ben, as you know, working together for so many years, that kind of fly under the radar of the mainstream press, but are very significant. They're often advances in space technology or medical technology, as you mentioned, or just down-to-earth things and so forth. We have one story that's wonderful about the water canals in California, as we'll find out a little bit later in the show. And so I look for these stories that just don't seem to get that much attention, but are very significant. And as you said, they could cover a very, very wide range of possibilities and fields of interest. So that's what's so much fun, though. That's what I love about doing these segments every week.
Absolutely. And so with that, we can, of course, start with story number 1. But real quick, I want to reiterate that over at Computer America, we'll have the show notes in their entirety. Ralph does a great job of, kind of lining them up. And everyone, hey, very, very easy to access. You can check that out. But Ralph, story number 1.
Yeah, story number 1, headline: scientists are using sound waves that could help regrow bone. Okay, this comes from a wonderful website, everybody. If you're at all interested in medical technology and advancements, medicalexpress.com is wonderful. And again, as Ben pointed out, the show notes will give you pictures and links, and you can dive deeper. And that reminds me, what I do and what Ben and I do together each Friday now is kind of a condensed I call it Reader's Digest, condensed highlights of these articles that I find and report on. And the links allow you, if you wish, to dive deeper because all of these stories have so much more information, so much more technical information, geeky information, if you will, if you want to explore. So once again, those show notes are so important. But once again, headline: scientists are using sound waves
to help regrow bone, medicalexpress.com. And also, there's an announcement from the Royal Melbourne Institute of Technology. We'll find out that's the source for the story. A couple of really cool illustrations with their captions here in the show notes. But here we go with the story. Researchers at the Royal Melbourne Institute of Technology, of course, this is in Australia, recently announced the use of sound waves to turn stem cells into bone cells. And this is an exciting tissue engineering advance that could one day help patients regrow bone lost to cancer or other degenerative diseases. And the new innovative stem cell treatment uses the precision power of high frequency sound waves. And okay, let's do a timeout here for a moment. We need a quick biology lesson refresh. Okay, what are stem cells? Stem cells are the body's raw materials, cells from which all other cells with specialized functions are generated. Under the right conditions in the body or in a laboratory, stem cells divide to form more cells that scientists call daughter cells. I don't know why they're not son cells, but they're daughter cells, okay? It's Women's History Month. We'll give you that. These daughter cells either become new stem cells or become specialized cells with more specific functions, such as blood cells, brain cells, heart muscle cells, or bone cells. Excuse me. No other cell in the body has the natural ability to generate new cell types. And there's an interesting illustration in the show notes kind of highlighting this variety of cells that stem cells can become. Now, going back to the issue of bone, a key challenge in regrowing bone is the need for large amounts of bone cells that will thrive and flourish once implanted in the target area. And to date, experimental processes to change adult stem cells into bone cells have used complicated and expensive equipment that have struggled with mass production, making widespread clinical application unrealistic. So where do we go from here? What do we do? And also, to date, the few clinical trials attempting to regrow bone have used stem cells extracted from a patient's bone marrow. And that, friends, is a highly painful procedure. So what's a new way to go? Recently, researchers at the Royal Melbourne Institute of Technology, of course, again in Australia, introduced a great alternative, treating stem cells with high frequency sound waves, turning them into bone cells quickly and efficiently. And by the way, as I said before, there's so much more technical depth and so much more science underpinning what I just said to you, because I thought to myself, wow, high frequency sound waves turning stem cells into bone cells quickly and efficiently. What an amazing stunt or accomplishment that is. Right. And more here on this. And the treatment was effective on multiple types of cells, including fat-derived stem cells, which are far less painful to extract from a patient. And the article also has some really interesting comments from the research team in Australia. They said this method also doesn't require any special bone-inducing drugs, and it's very easy to apply to the stem cells. And they go on to say, our study found this new approach has strong potential to be used for treating the stem cells before we either coat them onto an implant or inject them directly into the body for tissue engineering. And the high frequency sound waves used in the stem cell treatment were generated by a low-cost microchip device developed by the Royal Melbourne Institute of Technology. And the team spent over a decade researching the interaction of sound waves at frequencies above 10 megahertz with different materials. So applaud and hooray to our friends down under.
Yeah, it really reminds me of it's always like a standby for science fair for kids, where it's like, do plants grow better with different kinds of music? Trying to find, right. And I'm sure that's been a staple for science fairs for generations. Sure. But I mean, just turning new ways, and I definitely love how you point out, no additional drugs, which of course could complicate everything and have side effects.
Right.
Very, very interesting, and again fits with your theme of I definitely didn't catch this one when it was first published. So thank you for bringing that to our attention. Story number one.
I love this one. It's a great story.
Definitely. Now, story number 2. Well, this is back down to Earth because, because it's probably in the Earth, kind of. Well, it eventually got back down to Earth. So let's go ahead. Story number 2.
Story number 2. Yeah, we're going to go to outer space here for our next story. And basically, headline here is scientists discover rare asteroid that will follow the Earth in orbit for the next 4,000 years. Okay. Oh, and if you haven't seen the movie Don't Look Up, I think that's on Netflix, right? Is that Netflix or Amazon Prime?
Probably. I have not seen that, though.
It's Leonardo DiCaprio and another a cast of wonderful actors and actresses, and it's all about an asteroid that's coming to Earth, and it's going to hit Earth, and it's going to just take the planet out, and it's all about denial and denial of science and so forth and so on. If you haven't seen Don't Look Up, everybody, it's a real fun and kind of scary, terrifying movie all in one package. So anyway, I digress. So again, scientists discover rare asteroid that will follow Earth in orbit for the next 4,000 years. A couple of sources for this. A mainstream source was CBS News, and the other source that's in the show notes with links is scinews.com, which is a great outlet, by the way. So scientists recently proved the existence of what researchers call an Earth Trojan. I'd never heard about this. So again, they recently proved the existence of what researchers call an Earth Trojan, an asteroid that will be following us for 4,000 years. Now, an Earth Trojan is an object that shares the same orbit as our planet. And that was something interesting. I'd never heard of this before. Although Trojan asteroids have been known for decades, orbiting planets such as Venus, Mars, Jupiter, Uranus, and Neptune, it wasn't until 2011 that the asteroid 2010 TK7 was found to be the first Earth Trojan asteroid discovered. And recently, and I always love these stories too, Ben, one of the things I love to look for is when we have an international collaboration of scientists. And let me digress for a moment.
Sure.
What a world this would be if scientists around the world were running the show. I don't think we'd have we wouldn't have an invasion of Ukraine. We wouldn't have all of this foolishness, but I digress. So recently, an international team of astronomers led by the Institute of Cosmos Sciences, at the University of Barcelona announced the existence of the second Earth Trojan ever confirmed, called 2020 XL5. And they discovered this thing after a decade of searching for this elusive object. That's something to think about. And the researchers estimate that the asteroid's size, about 0.7 miles in diameter, will keep the asteroid in the sweet spot of gravitational pull, letting it orbit the Earth for the next 4,000 years. Wow.
What are and obviously the universe is a big place, but as always with space, it's always fun to think, what are the odds? What are the odds that an asteroid would be just in the right perfect position with just the right pull, everything? It's so incredible that they actually found this thing too, because like looking at the image, for everyone out there who's just listening to the radio and you can't see the image that they took of this thing,
right.
It's a beautiful cluster of about 9 pixels. But I guess that's enough to go off of.
Yeah. It's a fun, quirky story. And again, we all now know what Earth Trojans are. And one thing I wondered about, and I haven't found out yet, maybe I could dig deeper. Why Trojan? Trojan, you think of the Trojan horse, right? From, coming in and being a surprise inside. But how that relates to an asteroid that's sharing our orbit, I don't
maybe Earth's orbit is the Trojan horse, and then of course what's inside of that orbit or horse is other Trojans, which is this thing. I can only assume. I'm sure the scientists have a much better reason of answering that, but still very, very. And Ralph, I know that you didn't answer this. It might be in the article, but what do you think happens after 4,000 years? Does it just kind of it's like see you later and it goes off elsewhere? Or what happens after 4,000 years?
Well, yeah, that was not in the article. You raise a really good point. Does it drift off into space? But again, because of the gravitational pull, what is it about the 4,000 year period of time? Does it degrade in a certain way to lose its gravitational relationship?
Maybe they just
with
stopped
the Earth
running the simulator,
come into, would it enter our atmosphere, burn up harmlessly, or what? Something that's 0.7 miles in diameter is a pretty serious sized object. So let's hope it's not going to be hitting us.
Yeah, the dinosaurs need to watch out again, because that one is that's a huge asteroid. So okay, there you go. Story number 2.
That would be troubling.
Very, very much so, and I hope to never see it. And in 4,000 years, I'll let you know though. Story number 2. Story number 3, and this one we didn't actually cover on the show. I did see it, but I first of all, I kind of had a hint that maybe Ralph would pick up on this. This one though did get a lot of headlines, though again we didn't cover it on the show, so I'm happy that you brought it up again. So story number 3 is a very cool proposal, and it makes a lot of sense when you dig down into it.
Absolutely. I really love this story. And I look for stories that have to do with technology advancements or efforts to help fight climate change, or to help preserve or get the most out of our natural resources. So this story fits the bill beautifully. Headline: California is about to test its first solar panel covered water canals. And I have a couple of sources here: Smithsonian Magazine, wonderful article, and the Turlock Water and Power District website. That's the area of California in question. So both links are in the show notes. Be sure again to check that out. Wonderful illustration, a conceptual rendering is in the snow notes, or pardon me, in the show notes.
There you go.
And it's really, really cool. So here we go. So about 4,000 miles of canals transport water to some 35 million Californians to service 5.7 million acres of farmland across the state of California. So think about 4,000 miles of canals. Wow. Researchers at the University of California, Merced, proposed last year to start covering these canals with solar panels. And those of you in the audience who are lucky enough to be able to see what we're talking about because of the illustration can see the conceptual rendition. And it's not only cool, it's cool looking. I think it'd be a neat looking thing from aesthetics alone.
Right.
So again, the researchers, University of California, Merced, proposed last year to start covering these canals with solar panels to ding, 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 reduce evaporation of precious water and help meet the state's renewable energy goals because of the solar panels, while also saving money. Boy, this is a win-win-win. This is the first experiment in the United States to use solar panels to cover water canals, and it will begin this fall in the Turlock, that's Turlock, irrigation district of California's Central Valley. So you can get out your maps and find out where that is. The goal, no surprise, is to determine if this might be a viable large-scale solution. And if yes, and I think it will be, then the research team says that if you could cover all 4,000 miles of California's canals with solar panels, it would save more than 65 billion with a B, 65 billion gallons of water annually by reducing evaporation. Wow, that's enough to irrigate. And this number surprised me because I would have thought it'd be much more. But they say here in the article, enough to irrigate 50,000 acres of farmland or meet the residential water needs of more than 2 million people. That's just by saving from evaporation alone.
Right.
Just love it. Simple, direct, doable, executable. You're not taking up valuable farmland to create solar farms or disturbing the natural landscape in any way. These canals already exist, so cover them with these solar panels. And wow, I would also think it would help thwart dirt or dust or whatever getting into the water of the canals too. I mean, it would be like a roof, if you will, over the canal. So I don't see how you can go wrong. It's just a wonderful idea, I think.
Yeah, and so a couple of comments here. First of all would be, to your point about dirt and less sunlight and stuff like that. Anyone who's owned a fish tank knows how big of a problem algae can be. So I'm sure this would help reduce algae and stuff like that.
That's a good point.
Yeah, and kind of like you said, I mean, these things already exist, so why not just add a second use to help everything, kind of just flow better, just use the word flow. Now, Ralph, I will say that studies like these are very important because I believe we actually covered it with you a number of years ago. I don't know if you recall. There was a study in like Norway or Sweden or something like that, where they wanted to replace, it was a couple of miles with this plastic, hard plastic, but also solar paneling. So the road itself,
roadways, yes.
Yeah. I don't know if you remember the story where like the roads were made of plastic and they were solar panels. that study came to an end, and I don't know if you recall the findings of it. What they found was, it worked great for about a week, and then as people drove on it, they got dirty. Their efficiency went way down, and they either had to keep cleaning it and way more maintenance than an asphalt road, or they just left alone and no energy savings whatsoever. So it sounds great in theory. I mean, I'm sure everyone out there can think, wow, it would be a good idea to turn all roads in the United States into this cheap plastic solar panel. But in practice, it doesn't work as effectively. So that's, I'm sure, at this stage, Ralph, I hope that there's nothing that, kind of pops up. My immediate reaction, and like if I had to poke a hole in this at all, Ralph, would be solar panels only last a certain amount of time. I think the average lifespan is like 7 years or 10 years or something like that. I'm wondering, having them so close to water, what does that do for lifespan? I have no idea.
Well, it's an interesting point. Also, you made the comment, just made me realize as well. If you look at the illustration and look at the way these things are shaped, and go with me, you'll see where I'm going on this. You'll see the center. There's kind of three. Okay, people, if you're not able to see what we're talking about, let me give you a word picture.
Yeah,
it's spanning the canal. And this, in the illustration, it's a fairly wide one, the canal that is. And you'll see that there's a trifold for each solar panel array, if you want to call it that. Mm-hmm. And the left and right edges are tilted up, maybe not quite 45 degrees. And then the center panel, the big center panel spanning the canal, is arced. So where am I going with this? To your point about dirt and so forth, what little rain poor California gets compared to me up here in the Northwest. But it's designed, I'm presuming the design is such that when it rains, it would help flush and drain off any dust or residue to help further enhance the productivity, if you want to say that, of the solar panel. So that's an interesting thing. I hadn't even, until you brought that up about the road in the Netherlands. And that, by the way, was a story I got from Autodesk's Redshift website, which is a wonderful website. And it was a story about a company in the Netherlands using Autodesk design software to make those experimental roads and walkways too, by the way. But again, looking at this picture, I'm speculating that design is also there to anticipate helping rain clean, flush the panels. Maybe. That's my guess.
They and really, according to their renderings, they have kind of what it looks like before and what they kind of propose.
Yeah,
they have the different one that would span a wider distance. They have others that are just slanted to
there you go.
Completely,
to completely little irrigation ditches.
Just completely divert the flow of all that muck away from it. I don't know, and this is the fun part, Ralph. I mean, like everything they describe, like there's a reason to be hopeful that this will work because there's so many benefits.
Yes.
But now it's time to test it. So I'm looking forward to seeing the results of that. So perfect.
Yeah. And it's clever.
Yeah, and by the way, something else that I visited Texas not too long ago, and their power system is very privatized. That's I think that everyone knows that. They said that this power company, TD or TID, I think is TID, they're publicly owned. So I mean, as far as, kind of who you want doing your research and monetizing this thing, I mean, the public owns this. So if it works, then I think the people of California are in for a real treat. So good stuff there.
Yeah.
Yep.
Yeah.
Story number 3. Now, story number 4, the last one of all this. And again, if you want to find out more show notes, we have all this posted, including our past one, even on our YouTube channel. I don't shout this out enough. We actually have a whole category dedicated just to Ralph Bond. You can search all of his past segments there, and very, very simple. But Ralph, let's go ahead and skip over.
Yeah. So story number 4 to wrap things up today, and this is. I just love this because I loved Legos as a kid. My kids loved Legos as a kid, and my grandchildren love Duplos and Legos. I mean, so you'll see where I'm going with this in a moment. So the headline here is: a startup company turns unrecyclable plastic trash into indestructible construction blocks. And I got this information from two sources. First, the story in futurism.com. Again, we have the links, a wonderful outlet, by the way. And then I went to the company in question, which is called ByFusion. That's ByFusion Global is the name of the company. Their website, the link's in here. And there's even a story from apartmenttherapy.com, which is a very funny name, but an interesting outlet, by the way. And we have links for that. We even have a video link, which Ben is showing you right now. Really cool. But let's get into the story.
Mm-hmm.
An LA-based startup called ByFusion, that's ByFusion Global, so ByFusion Global, has developed a way for governments and companies and communities to recycle previously unrecyclable plastics into large, virtually indestructible building blocks. And the company, of course, since they're called ByFusion, they call these blocks BY blocks, BY blocks. So known as BY blocks, the building blocks are made using a 3-step process. And it's pretty darn simplistic in some ways. First, the plastic waste is collected, and then, of course, it's shredded. And then the plastic materials are superheated and fused to make BY blocks that, to me, look like multicolored, interlocking Lego blocks in a way, right? And the building blocks produced by this process are 16 inches by 8 inches by 8 inches. And they weigh each about 22 pounds. And here's the thing that's so much fun. And like Lego blocks, no adhesives are needed to snap, if you will, the blocks together. Because if you're looking at the video, you have the advantage of seeing how they have the same kind of protruding on one surface, protruding cylindrical
nubs,
nubs, and then the corresponding female indented receptacles on the underside of each block allows you to stack them like Legos.
Right.
And here's a cool point, and making these recycled plastic blocks produces 41% fewer greenhouse gas emissions than making concrete building blocks, which is what they're in a way offering an alternative to. And the ByFusion Global team claims their new BY blocks are the first construction grade building material made entirely from recycled plastic waste, which is kind of mind-blowing to me. I don't know if that's really true or not, because it's, when I read that line in the article, I thought, is that really true? Because, gosh, you would think lots of people have done this, but that's what they're claiming anyway.
I would imagine that anyone who claims that they have a recycled material, Ralph, I'm betting they have to use a second additive to, kind of make it, worth using again. This seems like they're just using heat and pressure and unrecyclable plastic to make these blocks. So yeah, I'm sure that there's no third party additive to make it hard or, stick together or anything like that.
Oh yeah. And just to segue here for a second from the notes, if you look at the images of these blocks, as Ben is showing you in the video and so forth, and they're multicolored. I'm turning my head to look at the monitor where you've got the video going. They're kind of cool looking. I think I might just leave them as is. I wouldn't paint over it or put drywall over it or anything necessarily, because they kind of look like, well, if you're an art history person, you know about Jackson Pollock, the famous painter who did the swirling drip paintings. It kind of looks like that. Anyway,
definitely out there.
Yeah. So again, we said that they claim they're the first construction building grade material made entirely out of recycled plastic. And again, the key is using quote unquote unrecyclable plastics, because everybody knows you look at the little triangle on the underside of your water bottle or whatever the object is, and if it's got a 1 or a 2, usually you can recycle that. But if it's got a number 5, you're not supposed to, and it has to go in the landfill. Well, why not take that stuff and make these things? And that's part of the premise of this company. So, and here's the important part, and you alluded to this a little bit too, Ben. And they claim that making these blocks does not require any chemicals, additives, adhesives, or fillers. It's the superheating and compression that's binding these blocks or making these blocks possible. And the plastics, if they use, don't even have to be sorted, cleaned, that's important, or processed before turning them into these building blocks they call BY blocks. And BY block can be swapped in for retaining walls, foundations, inner walls, particularly, I would think, non-load bearing, terraces, and any other project where a concrete block might be found. So again, it's meant to be sort of an alternative to concrete block. The block making machinery is now available. There are companies, ByFusion Global's block making machinery is now available for waste management companies, governments, and corporations to install to begin creating more sustainable building materials. So this is real. It's happening now. And there's a little kind of comically small activity going on in Boise, Idaho, but there's an early deployment experiment going on in Boise, Idaho. The company received a DOW grant and has partnered with the hefty trash bag companies, that's Dow, energy bag recycling program to run a pilot program in Boise, Idaho. So that's kind of an interesting deal. Here's the company that makes these plastic, some of the plastic stuff that's not recyclable, and they're teaming up with this company and the city of Boise, Idaho, to do this experiment. So along with providing the technology, the pilot program in Boise is slated to help Boise residents divert up to 72 tons of otherwise unrecyclable plastics from the local landfill, and has already used the blocks to build a bench. That's a very small little thing, a sitting bench in a city park, and more planned structures will be set to be built in the coming year. So of course they're starting off with something that's almost comically simple, like little seat benches, but I think that's kind of fun. But the bit about diverting 72 tons of otherwise unrecyclable plastics, to have that tonnage not go into a landfill and be there for millions of years doing nothing. Hey, let's put it to work and help it build our new future of construction.
Yeah, and this is always something worth kind of bringing up, because I think if people really looked into how things are recycled and if they are actually recycled, because Ralph, to your point, as far as the consumer goes, you look at the, if you're conscious about it, you look at the symbol, you look at the number, you submit it for recycling. What actually happens after that? By and large, it's usually sold by the tonnage to other countries, or it's shipped out to Southeast Asia or other recycling plants. Like, there's not a lot of recycling that actually happens here in America. So for them to come in and, have these things, and Ralph, what I really like about this company, yes, they're very small and, they just kind of started, but Ralph, as per their website, they are selling the blockers. They're selling the thing that actually makes the block to recycling facilities. And I think that, instead of them being, kind of the one-stop shop and they're going to handle it themselves, they're selling it to other people and could really make that take off. So, by the way, I already submitted a form. Hopefully we get them on the program. I would love to talk to them about, kind of what they do. I think at this early stage, it would be good to get the word out. But Ralph, this looks really, really cool. And, some rovers obviously in the chat room asking some questions. They're thick. They're very spongy, Ralph. I'm kind of curious, and you worked in construction. What are some of the other benefits that they didn't really outline? What's the insulation factor? What is the stress? And, how does it handle shifting and moving and stuff like that? A lot of construction questions, but I mean, I'm sure it would play to its favor, to its advantage. Like, I think it'd be good in all those areas.
Well, one thing that came to my mind immediately, and Ben made a passing reference to my experiences with the construction industry, which I'll explain. I was the last 10 years or so of my career before I retired. I was with Autodesk, the AutoCAD company, the computer-aided design company. Most of the audience may be familiar with them, but they have architecture, engineering, and construction division that focuses on software and technology and cloud-based computing solutions for the construction and architectural design industry. And it was an incredible joy for me to serve that division for 10 years. And boy, did I learn a lot. And I'm going to get to the point here in a moment. Friends, if you think the construction and building design industry is old school, roll out paper on a big desk, and construction is all just hand labor, no automation, no artificial intelligence, get that out of your head. In our century that we're in now is unbelievable. There's something called building information modeling. I won't go into that. You can look it up. The acronym's BIM, B-I-M, building information modeling. There are technologies that Autodesk and their colleagues around the world are promoting to the construction industry. But this story fits really well in that whole creative world of architecture, engineering, and construction today. And to the point about what these blocks could do that would be better than a concrete block, If you think about a foundation, let's just go there as one example. You think about a foundation, and then you think about a place like California, which, sad to say, is subject to earthquakes, or other parts of the world that suffer through earthquake problems. These plastic blocks would be much less brittle. So if they're subjected to this kind of oscillating motion and so forth, I'm going to guess, my intuition tells me that they're going to be much more able to deal with that kind of, as opposed to a concrete block, which by its nature is what it is. It's like kind of like a stone, or, well, I'm badly explaining it, but I think you get the picture, that would have a much more likelihood to crack. And also a water resistance, seepage resistance in a concrete, or pardon me, in a plastic materials block like this. And the fact that it's multiple forms of plastic fused together by its own nature gives it an advantage of, how can I describe this? It's like a composite, right? It's not just one material, it's multiple materials. And by default, I think the relative strengths of each of the different components contribute to a total tensile and flexibility strength all in one. I don't know. It's just, I love the video you're showing right now, because it really gives an idea of what you can see in doing with these blocks. And again, because they're like Lego blocks, gosh, how great is that? You can snap them together.
Construction seemed very, very simple. And of course, it's held together by rebar and, in ways to kind of keep it further secure. Like, obviously, Ralph, for a large skyscraper, probably not an option. You don't want these things flexing that much. But for simple structures and, more just everyday building, I mean, if nothing else, like, it seems like it serves wonderfully. And hey, this was recycled material to begin with. Like, why not use it? Still, all around, very cool. I definitely hope to hear from them and hopefully get them on the show to talk about, some of the benefits, some of the drawbacks. But overall, Ralph, yet again, you did it with, this is a story that definitely flew under my radar as well. So good job.
Hey, and Ben, by the way, the video segment you just showed a moment ago showed a fella taking a traditional concrete block and taking a big old heavy, probably a 5-pound or 10-pound hammer, and beating it and fragmenting the block. Exactly my point. It's a concrete block is going to, by its nature, he drops it on the floor and it falls apart, which that's amazing. And then he takes the buy block made out of the plastic and beats the heck out of it, and nothing happens. And so that's my point about its value to a building or construction program. So very cool stuff.
Yeah, definitely. So of course, we hope to hear more from that. Everyone, we're going to go ahead and play the music there. We're about done, but it was a very fun segment. If you want to find out more, Ralph Bond Wicks in Google and his website pop up, or head on over to our website and we have a link to his site right there. So Ralph, until next Friday, I want to thank you for taking the time. Everyone, we hope you enjoyed it. Have a great day. Have a good one, everyone. Bye-bye.